Hi guys, greetings of the day. Myself Vijay Tavardhan. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VQ syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on the bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now, let's start the session number 26, which is based on the pressure reducing or pressure regulating valve. What is called as pressure reducing valve? Pressure reducing valves are valves for maintaining secondary and lower pressure in hydraulic system. The vessels are normally open two-way valve that closes when subjected to downstream pressure. There are two types of pressure reducing valves. One is called as a direct pressure reducing valve and the other one is called as pilot operated pressure reducing valve. Out of which we will discuss what is called as direct acting pressure reducing valve. This uses a spring loaded spool to control the downstream pressure, which you can see the figure, which shows a direct acting pressure valve both in normal and actuated positions and its graphical symbolic representation. When the pressure of the branch outlet is less than or equal to the valve setting, free flow takes place between the inlet and the outlet as shown in the figure 1. An internal connection in the form of a passage transmits the outlet pressure to the spool end opposing the spring. When the branch outlet pressure rises above the wall setting, the spool is moved against the spring, which in turn partly blocks the outlet part as shown in the figure 2, allowing only sufficient flow to the outlet, thus maintaining the reduced or regulated pressure. Pressure regulation can be made by operating the knob, which can be set at a different pressure. In case the valve closes completely, leakage past the passage could cause buildup of pressure in the circuit. This is prevented by continuous bleeding to the tank through the separate passage provided to the return this leakage flow to the tank. Then coming to the next type, that is called as pilot operated pressure reducing valves. The pilot operated pressure reducing valves have wider range of pressure adjustments and also generally provide more accurate control. The operating pressure is set to the pilot stage by an adjustable spring provided in the upper body. The spool in the lower body functions similar to direct acting pressure reducing valve, and the figure shows the pressure reducing valve, its positions at the set pressure. This is similar in construction and operation to pilot operated pressure relief valve except for spool shape, which you can observe. Flow through the orifice in the spool develops the pressure difference which moves the spool against the spring force. This results in spool partially closing the outlet port and creates a pressure drop in the supply to the branch system. If no flow is required in the low pressure secondary circuit during a portion of the cycle, the main valve closes by moving to the right. Any leakage of high pressure oil into the secondary circuit, the oil returns to the tank through the pilot operated valve drain. A pilot operated pressure reducing valves are generally have wider range of spring adjustment than direct acting type and usually provide greater repeatability. However, contamination in the oil can block the flow to the valve, keeping the main valve completely closed. This is one of the drawbacks. Then coming to the next type of valve, that is called as pressure unloading valve. A pressure unloading valve unload the fluid energy at a lower pressure, whereas the pressure relief valve unload the fluid energy at full system pressure, obviously resulting in higher quantity of energy loss. The necessity of unloading of energy arises when two pumps are used which provide large volume of oil at a low pressure, and one of them must be unloaded during a specific period when small quantity of oil is required at high pressure. This will save the system from undesired heat energy to great extent. It consists of a primary and secondary port. The primary port is connected to the pump and the secondary port to the tank. A spool with A piston is housed inside the valve. The movement of the spool is controlled by the external signal, which in turn controls the passage of the secondary port. The spool is provided with a hold through it, and the movement of the spool is controlled by the difference in pressure between the primary port and the force or pressure extended by the spring. The spool in turn controls the passage of the secondary port, and based on its position, the extra energy is unloaded into the tank through the secondary port. The figure shows the closed and unloading positions of the valve when the system pressure acting on the piston is too low and the valve remains closed. If the system pressure exceeds the set pressure, it acts on the spring, compressing it. Thereby, the spool is moved. Thus, in turn, opens the passage to the secondary port and the energy flows into the tank. This continues till the system pressure reduces to the set pressure. This is how the pressure unloading valve is going to be worked. Then coming to the next concept, that is called as pressure sequence valve, is used in a hydraulic system for operations in a definite or sequential order, that is one after another with many actuators in hydraulic system. For example, the sequence may be clamping the job followed by the machining operation. Now figure shows the assembled view of a two position pressure sequence valve. The hydraulic circuit containing this may permit the clamping operation to take place first, followed by machining operation. Sequence valves are normally closed two-way valves that regulate the sequence of functions to occur in a hydraulic circuit. In this valve, the fluid flow freely through the primary port to operate the first phase until the pressure setting of the valve is reached. As the spool moves to the left, the flow of the fluid is diverted to the secondary port to operate second sequence. Sequence valves resembles direct acting relief valves except that their spring chambers are generally drained externally to tank instead of internally to an outlet port. To maintain pressure in the first phase, the valve is internally operated. The drain connection is made external since secondary port is under pressure when the valve is sequencing. The sequencing valve can be pilot operated type also. Upon working, normally a sequence valve routes pressurized fluid to a second function only after the earlier function has been completed. When normally closed, the sequence valve allows the fluid to flow freely to primary circuit to perform its first function until the valve's pressure setting is reached. When the primary function is carried out, pressure in the primary circuit rises and is sensed in pressure sensing passage. This pressurizes fluid acting on the spool and overcomes the force exerted by the spring. The spring is compressed, the spool shifts, and the fluid flows to the secondary circuit. This is how the pressure sequence valve was working. Next, we are going to discuss about the next part is called as pressure counterbalancing valve. A counterbalancing valve is normally a closed valve used to counterbalance a weight or external force or counteract a weight from falling. It consists of a primary port which is connected to the lower end of the cylinder, and a secondary port is connected to the upper end of the cylinder through a direction control valve. Now figure shows a pressure counterbalancing valve. The pressure setting of valve is slightly higher than required to hold the load from falling. And how does it work? When the pressure fluid flows to the hydraulic cylinder's head end, the cylinder extends, increasing pressure in rod end and shifting the main spool valve in the counterbalance valve. This creates a path which permits fluid to flow through the secondary port to the directional control valve and to reservoir. As the load is raised, the integral check valve opens to allow the cylinder to retract freely. Counterbalance valves are usually drained internally. When cylinder extends, the valve will open. Its secondary port is connected to reservoir. When the cylinder retracts, it matters little that load pressure is felt in drain pressure because the check valve bypasses the valve spool. If it is necessary to relieve back pressure at the cylinder and increase the force at the bottom of the stroke, the counterbalance valve can be operated remotely. Counterbalance valves often use a pilot signal, usually from the inlet of the actuator, to assist in the opening of the spool. This assist makes the valve more efficient and reduces the horsepower requirement and the heat generation within the system. And by this, the time set for the session has been came to an end. So thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavartan.